Good morning, everyone. First and foremost, I would like to thank Mehdi and all APIdays staff for organizing these awesome conferences all over the world. It's really a pleasure and an honor for me to be here today. My name is Arnaud Lauret. I'm an architect at AXA Bank. It's a French retail bank. And on my spare time, I also share my idea and experience concerning API as API handyman. You may have seen some of my tweets and my post on my blog. Today, I would like to tell you a story, not history, not a perfect guide to make APIs, but a story. So, the events depicted in this talk are fictitious. Any similarity to any information system, living or dead, is merely coincidental. So, once that is said, this story is about a quest for simplicity which will lead us from the depths of an imaginary bank's information system to the heights of its API. What is your quest? What is our quest? API or the thing. We all want to make APIs. But it's easy to say, if your company, especially a bank, has an old information system, an ugly, old, and complex information system with mainframes, old core banking system, complex functionalities, complex processes, complex business rules, an information system who has been there for years or even decades. Providing an access to this old information system to programs is not an easy task. What is your favorite word in API? Is it application? Please raise your hand if you think that application is the most important word in API. No? Programming? Interface? Great, because I wanted to talk about interface. What should we care about this particular word, about this concept? An interface is a place at which independent and often unrelated systems meet and interact with each other. Independent, unrelated systems interacting. APIdays is an interface. You go here, you can meet people you didn't know and discuss with them. Some interface that I found in my home. There's a door handle, a light switch, my MacBook keyboard, some kitchen appliance panel control, also a Famicom gamepad. I like all video games. And of course, an API used with Postman. What all of these interfaces have in common? Us? APIs interface are used by people and even APIs. An API should be seen as a user interface. APIs are for people building programs. APIs are not only for programs. You must not forget that. So, interfaces are used by people. But what's happening behind the interface when we use it? Every morning, I wake up, get out of my bed, turn on the light in my bedroom, open my bedroom door, go to the main room of my apartment, take my favorite mug, pour water in it, put my mug in my microwave oven, turn the timer knob, the one on the top, to 90 seconds, wait 90 seconds, take the mug, put a tea bag in the water. Who knows what's happening in a microwave oven? Are there people who knows? Personally, I don't know. Could we guess what's happening in a microwave oven just by looking at its interface? No. And besides people working in the microwave oven business, who cares about what's happening in a microwave oven? Nobody. An interface is an abstraction. So to explain abstraction, I will use picture instead of 1,000 words. This is a tree painted by someone called Piet Mondrian. Piet Mondrian is one of the fathers of the abstraction. His painting has evolved from representational painting to abstraction gradually. And in the end, these paintings are completely disconnected from reality. When you design interface, you have all these levels of abstraction at your hand. You just have to choose a good one depending on the context, on the audience. Interface are only a representation of an underlying system. There must not be a direct window to what's happening behind. What do we seek when we use an interface, especially an API? Simplicity. Simplicity is the quality of being easy to use and understand. Simplicity implies that an interface is easy to use. What would you prefer if you have to program? Would you prefer to work on an Apple II with a keyboard and a screen? Or to work with an Altair 8800? To program on this computer, you have to use the little switch to input binary data and see the result through LEDs. There must be here some cool graphics, but I did not find them. So an interface must be easy to understand. Would you prefer have something like missing email when you do an error, or an obscure code that you didn't know what it means? But don't get me wrong. Being simple does not mean being simplistic. We just need to take care of the targeted audience and the context to choose an adapted abstraction. So, what is our quest? Simplify all the thing. And now we will start our quest as an imaginary bank owning an ugly and complex information system. Our goal is to provide an interface to our AS that is simple. A long time ago, when our bank was totally new, at that time when customers wanted to interact with a bank, the only available interface was a person. You have to go to a brick and mortar bank, talk to a clerk, and this guy will interact with a core banking system for you. But at the imaginary bank, we have ideas. We want to innovate. We want to give access to our system to our customer. Our first idea would be to offer a service allowing you to know your balance account by just calling a phone number. With an IVR, an interactive voice response, you would call a number, enter some credentials using the keypad of your phone, and get your balance in real time without the need of a bank employee or without the need of waiting for a monthly bank statement. So at that time, the imaginary bank IS consisted of the CBS, the core banking system, a big software and a huge database. To build the IVR, we need to store a login and a password. So we'll store them on a new database, independent from the CBS database. And once logged, we want to access the bank data. So we'll do that by directly accessing the CBS database. Accessing a database is fairly easy, but the CBS database is quite complex. Do people here work with core banking systems on mainframes and with such kind of tables like that, with this ZBLA0? Who can knows what's the meaning of this? Only the guy who works with it. So we have succeeded building the IVR, but this application is tightly coupled with the CBS. A few months later, in France, some people invented the FWW, the France Wide Web. All right, it was not the web. It was something called Minitel. It was a video text online services accessible through telephone line. And the Minitel network was one of the most successful public networks of the pre-web era. 25 million of users in the 80s. With a Minitel, you could find someone's phone number, purchase plane or train tickets, see the movies who are now playing at your theater, and even buying things like clothes. Amazon could have started on the Minitel. What an amazing thing. We should make an app for that. In fact, it was not called an app, but a service. So, here is our information system. The easier way of creating this new application was to reuse the non-CBS database with the login and password. Then also access the CBS database to read the bank data. And we want to do a wire transfer with this application. For read operation, we need to access directly the CBS software. And this is done by using a messaging system, MQ. And we have to send message like this. Pretty awful. Can somebody explain what's happening here? I defy you to describe the message here. So again, we have built an application with functional. For the end users, it's really great. But for our system, this application is tightly coupled to the CBS. So is it simple to interface with the CBS? Is it easy to use? Well, when we see the database, the MQ things, not really. Is it easy to understand when we see the table in the database and the message we have to use? Not really. Is the abstraction adapted to the audience, as yes, applications are only built by internal developers? We could say yes, but it's not an abstraction. It's a direct access to the system. So it's not simple. It's just like programming on an Altair RT800. A few years later, we are in the future, and I have a bad news. Who knows what is this? A turkey? No. It's a dinosaur. Yes, dinosaurs have evolved to become birds. Dinosaurs are still alive, just like our good old information system. The CBS is still here. He has barely evolved. We just have had another application because the web is there now. And the web functions just like the Minitel. We have now 3 different apps offering the same functionalities but coded 3 times. And these apps are strongly tied to the CBS. So each time the CBS evolves, we have to evolve these apps. One day, some people invented SOA, ServiceOriented Architecture. The principles of SOA are the service. The service is a logical representation of a repeatable business activity. For example, get an account balance or do a wire transfer. Services are supposed to be organized by business domain. Loose coupling. The service and its consumer do not have to know what's happening inside each other. A service could be seen as a black box, just like the microwave oven. And reusability. If I build a service who allows me to do a wire transfer, I can use this service in my Minitel app, in a website, or whatever will come after that. SOA is mainly built on the system with the SOAP protocol. The SOAP protocol uses HTTP as a transport protocol. You do post on some URL, and in the body you put audio data. These data are in XML format. And when you put the data, you just indicate the action you want to trigger. So, that sounds good. We could get rid of all our duplication of codes and build new applications faster. I heard that a company is doing that, a company called Amazon. So, let's go and build web services and do that, or you're fired. They do that also at Amazon. The first part of the project was to build SOAP services for our website, and then after that reuse the services to our next application. With this architecture, all the duplicated code goes in the yellow box, the SOAP services. And then the application just needs to call the services. Several years later, the SOA program was a bit longer than expected. Even if the SOA principles are good, the SOA program itself had not fulfilled its promises and just end up in a JBoss, just a bunch of web services. Also, as a frontier between web services provider and web services consumer was not clearly defined, when the services have been built for the web applications, there are some errors, and it ends that the web application has many business rules inside her. So if you want to build another application using your JBoss, you have to recode these business rules in this new application. So again, we have some tight coupling between the applications and the underlying system. There are also some services who are such tailor-made for the web application that they can hardly be reused. So, is interfacing SOA with SOA simple? Well, it's easy to use. We can say that because we just have to do some posts on URL with XML data. Is it easy to understand? Yes, better than the CBS because we have put a layer of abstraction of this, on top of this system. But we have still to implement some business logic in our application. Is the abstraction adapted to the audience? As the application who use these services are only built by internal developer, we could say yes. So it's better, but not awesome. Let's see how all this evolves in the future. APIs. One day someone tell, this is an iPhone. Cool. Let's convert our Minitel application to an iPhone application. So to interact with our information system, the mobile application needs an interface. This is why we build the MMW, the mobile middleware. This mobile middleware will expose an API to our application. It starts with a ROAST API. What is a ROAST API? It's a SOAP API made by people who have vaguely heard of REST API. A ROAST API is an accidental API built without realizing it. This kind of API is only seen as a necessary evil allowing to allow mobile application to access VIS. Roast API recipe. First, you take a SOAP XML web services name, add a slash before it. You choose randomly an HTTP method, put it before the slash. You transform input and output from XML to JSON. If the method is get or delete, you put all parameters in query variables, and be sure to always return HTTP status to 100. Of course, when the guys you hired to build your mobile API because you don't have mobile developer, they were not quite happy with your API. Several years later, so we have learned from our mistakes, we have built several applications, and we know now that we need to build real APIs. It's time to take APIs matter seriously. So we are going to build a REST API. First principle, design first. An API is not the thing you do at the end of a project. You design it first. It's a product, it's a user interface. So we need to design it. I will not explain all the things about REST API, so I will pass this relatively quickly. So you have to use resource instead of actions. You have to use relevant HTTP method. Relevant HTTP status, for example, 403 when you don't have enough money to do a wire transfer, 303 when transfer service is not available. And most of all, you have to provide hypermedia controls. For example, here, the first one, Takeshi's Castle, knock knock. You always provide all hypermedia controls even if they are not available. So if you cannot do a transfer, you will get an error because you don't have enough money. Even if you have enough money, the service can be unavailable. The second option, this is bowling. There are rules. You provide only the controls that you can actually do. Here, I don't have enough money, no transfer action. Walter Sobchak can understand that. Here, Walter has plenty of money. You don't understand why he can do a wire transfer. It's because the backend system is unavailable. Last option, the Jude abides. Here, you provide all the hypermedia controls, and you say if they are available or not, if you can use them or not. Here, I cannot do a transfer because I don't have enough money, so I will not try to do it because I know I can do it. The same thing for when the system is not unavailable. Is it, not it, really simple so to design an API? Yes and no. I've quickly passed on all these principles. They are fairly easy to understand, but when it comes to design an API, you have to take your time. You have to design, test, design, test, design, test, until you feel comfortable with it. And after that, you have to let the consumer of your APIs tell you if it's okay or not and react. So, interfacing with a RESTful API, is it simple? Is it easy to use? Definitely yes. Easy to understand? Yes. Is the extraction adapted to the agents? It will be up to you to define the good API for that. And make your IS simple as Lego bricks. Is it the end? Who knows what comes next?